Hello, I am Andre. I am a mathematics education student at Sampurna University. Nice to meet you. Now, we learned about related weights with a problem, the speed of an airplane tracked by radar. Do you see the airplane? Yeah, we can see the airplane move from one point go to the other point, right? So, the problem is how do we can find the weight of the airplane? Before we solve the problem, we have to know about the important thing. That is, we should know the strategies to solve the problem. These are guidelines for solving related weight problems. 1. Identify all given quantities and quantities to be determined. Make a sketch and label the quantities. 2. Write an equation involving the variables whose rates of change either are given or are to be determined. 3. Using the chain rule, implicitly differentiate both sides of the equation with respect to time t. 4. After completing step 3, substitute into the resulting equation of known values for the variables and their rates of change. Then, solve for the required rate of change. After we know the guidelines for solving related weight problems, now we have a problem that we have to solve. The problem given in a question. The question is about air traffic control. An airplane is flying at an altitude of 5 miles and passes directly over a radar antenna. See the illustration. When the plane is 10 miles away, the radar detects that the distance is changing at a rate of 240 miles per hour. What is the speed of the plane? To solve the problem, we have to follow the guidelines. Guideline 1. Solution. We know that y equal to 5 miles. Given rate, ds over dt equal to 240 miles when s equal to 10. Find dx over dt when y equal to 5 and s equal to 10. This is the illustration from the question. Based on the illustration, we know that let x be the horizontal distance from the radar antenna, s be the distance between the plane and radar antenna, and then the plane flight of the h for 5 miles from the radar antenna. Guideline 2. From the illustration, we know that the activity of the plane makes a right triangle. Therefore, we can use the Pythagorean Theorem for solving the problem. Do you remember the Pythagorean Theorem? Yeah, the Pythagorean Theorem has an equation like you see. That is, a squared plus b squared equal to c squared. Thus, we can write the equation like x squared plus y squared equal to s squared. Then, we are able directly to substitute the value of y equal to 5 into the equation. Because if we differentiate 5 squared, so that means equal to 0. Where if we don't do that, so when the equation differentiated, that means we have dy over dt, right? Meanwhile, we don't have, and the equation is not given for us about the value or quantity of dy over dt. so that we can write the equation like x squared plus 5 squared equal to s squared. Guideline 3. Differentiate with respect to t. We are going to differentiate x squared plus 5 squared equal to s squared, so that it will be 2x times dx over dt plus 0 equal to 2s times ds over dt. Then it's becoming 2x times dx over dt equal to 2s times ds over dt. Then it's becoming dx over dt equal to 2s over 2x times ds over dt. And then it's becoming dx over dt equal to s over x times ds over dt. Guideline 4. Substitute for s, x, and ds over dt. Now, before we do that, we have to find the value of x. We find x use the Pythagorean Theorem. That is, x squared plus y squared equal to s squared. X equal to square root s squared minus y squared equal to square root 10 squared minus 5 squared equal to square root 100 minus 25 equal to square root 77. X equal to square root 25 times 3 equal to 5 square root 3. Now, let's do substitutes as x and ds over dt. Dx over dt equal to s over x times ds over dt equal to 10 over 5 square 3 times 240 equal to 10 times 240 over 5 root 3 equal to 480 over square root 3 equal to 480 root 3 over 3. So dx over dt equal to 277.12 miles per hour. So the speed of the airplane is 277.12 miles per hour. Important to know, if the velocity is negative, that means x represents a distance that is decreasing. Meanwhile, if the velocity is positive, that means x represents a distance that is increasing. These are references of my project. Yay! We are already done solving the problem. I hope you can enjoy this video and it can improve your knowledge about the related rates. Thank you for watching and see you.